Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from October-November 2022 paper 1. And in this lesson, we will discuss these questions in detail so you can have better understanding of these questions and also you can improve your conceptual understanding of these topics. Let's study together. Let's improve together. In today's class, we are talking about October-November 2022 paper 1. Total time for this exam is 1 hour and 15 minutes. And there are 40 questions on this paper and you need to answer all the questions. And total mark for this paper is 40. It simply means that you have 1.8 minutes for each question. On the second page of exam paper, you can also find values of some constants, and if you need value of any constant for some calculations in your exam, you can come to the second page of your exam paper and you can find value of constant. And for AS physics, you will need these values of constant. So these are for AS physics. So it's very important to understand that values of some constants are given to you. And if you need value of any constant, you can come to this page and you can find values of constant. And if we go to the next page, actually it is the same page, you can also find some important formulae. Means you can find some basic formulae, but these formulas are not for whole AS physics. I mean, these are not all the formulae you need for AS physics, but these are some important formulae. You will need them for some calculations. So if any formula you have forgotten and you need that one, you can come to the second page and you can also find important formulae on this page. For question number 1, it is given to us a train of mass 600,000 kgs moves with a speed of 100 kilometers per hour. What is the order of magnitude of the kinetic energy of the train? So first of all, we need to convert speed into meters per second. So simply we can say in this case we have 100 kilometers per hour. We have to convert this one into meters per second. So simply we can write on here we have 100 kilometers per hour, and we will multiply this one with 1 kilometer in denominator, so we can get rid of kilometer with kilometer, and 1 kilometer is equal to 1000 meters. And we need to get rid of hours, so we can multiply with this 1 hour, and we need to divide by 1 hour as well, and 1 hour has 3600 seconds. So now simply we can cancel. So in this case, kilometer we can cancel with kilometer, hour we can cancel with hour. So we have 100 kilometers per hour is equal to this many meters per second. We can also cancel these two zeros with this one. So simply we left behind 1000 meters per second divided by 36, and if we solve this one, our answer will be 27.7 meters per second. So we have converted 100 kilometers per hour into meters per second. And now we need to calculate kinetic energy. And kinetic energy, simply we can calculate kinetic energy is equal to 1/2 mv square, and value of mass we have, and value of speed also we have calculated. So this is value of mass, and we need to multiply with 27.7 square. If we solve this, our answer will be 2.31 times 10 to 8 joules. So this is value of kinetic energy. For this question, we need to find order of magnitude. Order of magnitude. So this is order of magnitude. So the answer for this question is B. For the second question, we need to find out what are the SI base units of electromotive force. So first of all, we need to understand electromotive force. Electromotive force simply is equal to energy transferred per unit charge. Energy transferred. So we can say EMF is energy transferred per unit charge. Means energy transferred from chemical energy, or simply we can say from any other form of energy to electrical energy per unit charge. We call that is electromotive force in a battery. So we can say energy transferred per unit charge. So this is the first main concept you need to understand. Energy transfer per unit charge. Now we can write down this is E divided by Q. Energy transfer per unit charge. Now we need to understand SI base units for energy. You can use any formula for energy. I will be using mgh because this is quite straightforward one. So for mass we have kg, for g we have meter per second square, and for height we have meter. So SI base units for energy we have kg meter square per second square, and we can also write down SI base units for coulomb. Q is equal to IT, and SI unit for I is ampere, and for time is second. So simply we can write down base units for energy and charge here now. For energy we have that is kg meter square per second square, and for charge we have ampere second. Now if we simplify this one, we can write down kg, and here we will have meter square, ampere, power will be -1, and this power of s is positive, and in numerator this one will be negative. This is how we can find SI base units for EMF. So the answer for this question should be B. So B is the right answer. For our third question, it is given to us: a digital meter is used to measure current in an electric circuit. The reading on the meter fluctuates between 3.04 amps and 3.08 amps. The readings on the meter have an accuracy of ±1%. We need to find out what is the true value of current with its uncertainty. Pretty straightforward question, and also this question is a repeated question. I think you can find this one in 2021 October, November. You can find the same question, 100% same question. So first thing we can say, this question is a repeated question. So you can also see this one in the past papers. Now we need to calculate true value with its uncertainty. To calculate uncertainty, simply we will use this method. To calculate uncertainty, we will use half range method. So we will take the maximum value, maximum minus minimum, and we will divide by 2. So you can calculate uncertainty. So what is the maximum value? So first of all, we will take maximum value. Maximum value in this case is 3.08 plus 1%. So plus 1% means 1% of this one. So the 1% of this one will be 0.03, and this is 3.08. So we will get 3.11, and we can also find the minimum value. So this one has to be minimum value. We are talking about minimum. So this is the minimum. So this is 3.04. So we will subtract 1% of this value, means 0.03. So we will get this is 3.01. And now we can find out uncertainty. So we have maximum value 3.11 and minimum value we have 3.01, and this is divided by 2. So we will get 0.05. So this is the absolute uncertainty. I mean, this is the value of uncertainty. Absolute uncertainty we have calculated. Now we need to find the true value. True value we have to find out. True value means the mean value. Mean value we can calculate. That will be 3.08 plus we have 3.04, and this is divided by 2. So we will get in this case 3.06. So this is the mean value, means this is the true value. So we can write down in this case our final measurement, or simply we can say final answer. Final answer in this case is final value. It's better to say the final value, or you can say the final reading. The proper way to say this one, final reading, when you will write down in this form: 3.06 plus minus 0.05. So this is how you need to write down your final reading or final measurement. So the answer in this case will be C. So this one is the right answer. This is a beautiful way to answer this question. I can use another method, long method. I can calculate separate, then I can combine, but this is a beautiful way to answer this problem. For question number 4, we need to find out which quantity is a vector quantity. Density is not a vector quantity. Mass is not a vector quantity. Volume is not a vector quantity. Weight is a vector quantity. So the answer for this question is D. For question number 5, it is is given to us. A stone is projected horizontally at time t is equal to 0 and falls. A, resistance is negligible. The stone has horizontal component of velocity vh and a vertical component of velocity vv. V sub v. Which graph shows how vh and v sub v vary with time t? So for this one, we need to understand horizontal motion and we need to understand vertical motion. So we can simply write down, first of all, for vertical motion. So we will be writing for vertical motion here, and then we will be talking about horizontal motion. And in this case we throw stone horizontally, so we can imagine this one is the stone and we throw this one horizontally, so the stone will go like this. So we can also imagine this one is the ground, this is the ground. So when the stone is falling, only one force is acting on the stone, and that force is the gravity, means the weight is acting downward. So the net force on the stone is weight, so it is accelerating downward. So we will say acceleration vertically, A is equal to G. But there is no force along horizontal. So we will say along horizontal there is no force. As there is no force along horizontal, so we will say horizontal acceleration, we can say V sub H, this one is equal to 0. We can say AV means along vertical acceleration is equal to G. So it has constant acceleration. So along vertical we can say acceleration is equal to G, but along horizontal acceleration is equal to 0. So acceleration is equal to 0, it simply means that horizontal velocity will not change, it will stay constant. But there is acceleration along vertical, it means vertical velocity will keep on increasing with constant value. So these 2 points we need to understand. So we will say VV, it will increase with time, but rate of increase will be constant, means the gradient of the graph has to be constant. So in this case we can say the gradient of line has to be equal to 0, because we have VT graph, means V against time graph. So gradient has to be 0, yes, line has to be horizontal, and in this case gradient has to be positive or gradient has to be negative, but constant gradient. So we will say in this case gradient has to be constant and non-zero. So we will say constant and non-zero. So we can write on this point. I'm writing this one for proper understanding. Maybe some of you need this much detail. Constant and non-zero. Now if we look at option B, so this is telling us VV is constant. So the gradient of this one is not non-zero. So this one is not possible. And this is also not possible because its gradient has to be 0. So B is not possible. If you look at C, in this case VH is constant, this one is right, but this gradient is increasing, this gradient has to be constant, so this is also not possible. VH, this is right because gradient is constant, gradient constant and 0, constant means 0, constant also means 0, and in this case gradient is increasing and this is wrong. So if you look at option A, in this case VV means V sub V, velocity is increasing at constant rate. Rate of increase of velocity is constant, gradient is constant and non-zero, so this one is right. And gradient of horizontal velocity, this one is constant and this is 0, so it means this is possible. So the answer for this question is A. This is very straightforward question. If I just simply look at this one, I can understand velocity, vertical velocity has to increase at a constant rate and horizontal velocity has to be constant, so the answer for this one is A. I try to explain you in detail, maybe some of you need this much explanation, so that's the main reason of explaining in detail. For question number 6, it is given to us: on Earth, an object takes time t sub e to fall from rest through a vertical distance h. On the Moon, the same object takes time t sub m to fall from rest through the same vertical distance h. The ratio acceleration of free fall on Earth divided by acceleration of free fall on the Moon is equal to 6. It simply means that a sub e divided by a sub m, this is equal to 6. From here we can say that A sub E, this is equal to 6 times of A sub M. So we can get this information from this ratio. And it is given to us A resistance is negligible for the object on the earth and on the moon. And we need to find the ratio between T sub E and T sub M. So the best way to answer this question is, in this case, it is given to us same vertical distance, and they start from rest. So we can start with kinematic equation, because in this case, acceleration will be constant and objects are starting from rest. So simply we can say S is equal to ut plus 1/2 at square. In this case, initial velocity is 0 because they're starting from the rest. So this one is equal to 0. So we can write on S, that is equal to h, and this is equal to 1/2 at square. And we can rearrange. We can write on 2h. This one will be equal to at square. As they have the same height, it means this is constant. At square, it means it's constant for two stones on the moon and also on the earth. Means the product of this one is constant. So we can start with this one. We can say A sub E times T sub E square. This one has to be equal to A sub M times T sub M square. And we need to find the ratio between TE by TM. So we can rearrange this one. So we can say T sub E square divided by T sub M square. This one will be equal to AM divided by AE. But AM is AE. This is equal to 6 AM. So we can replace AE with AM. And we need to find out, in this case, TE by TM. So this is TE by TM. So we can take square root on both sides. So here we will get, this will be AM divided by 6 AM, root of this one. So AM, we can cancel with AM. So simply we left with 1 over 6, root of 1 over 6. So the answer for this question is B. So this is how you can approach this type of problems. For question number 7, it is given to us a cyclist in still air pedals as hard as she can. She reaches a maximum speed. However, after a certain time, her maximum speed increases. What could be a possible cause for this? If you look at option A, she cycles into a wind. If she cycles into a wind, she will hit the wind, and wind will hit back on her. So her speed should decrease. So this is not possible. She cycles over rougher ground. Due to friction, speed will also decrease. So speed will not increase. She sits more upright on the bicycle. It doesn't gonna increase or decrease the speed. No big difference. So it means this is also not possible. She starts to travel downhill. This is possible. Means, first of all, she's traveling here, then she starts traveling downhill. So the speed will increase. So this can be a possible cause. So the answer for this question is D. For question number 8, it is given to us a ball of mass 0.5 kgs hits a vertical wall at a speed of 12 meters per second. It bounces back along its original path with a speed of 8 meters per second. The collision lasts for 0.10 seconds. We need to find out what is the average force on the ball due to collision. Very common question in every year, in every past paper. There will be one question about collision where you need to calculate average force. So it's very important to understand, or it's very important to master this concept. So let's try to understand this question. So you need to calculate average force. So the F average, in this case, simply we can calculate. That one will be equal to the total change in momentum divided by total time taken. So we can calculate average net force on the ball. So you can calculate like this, change in momentum. So in this case, we will take to the left is positive. So we will take to the left positive because the resultant force will be in this direction. So we will take to the left is positive. So our answer will be positive. So in this case, we can simply write down this is M times delta V, M times delta V divided by delta T. As in this case, mass remains constant. So we can take mass out. we can write down V minus U divided by delta T, time taken. So this is over V, and V in this case is positive because we have taken to the left is positive, and the U is negative because to the right will be negative. Now simply we need to plug in values. So in this case, value of mass is 0.5, final velocity is 8, initial velocity is minus 12, and this is divided by time taken, that is 0.10. Now if we solve this one, we will get 0.5, and here we will get 20, and this is divided by 0.10. Now if we solve this one, our final answer in this case will be equal to 100, because this one, if we solve this part, 0.5 multiplied by 20, we will get 10, and 10 divided by 0.10. So here we have 10, so this is divided by 10, 10 divided by 100, so we can write down this is 10 divided by 10 multiplied by 100, so the final answer is 100 newtons. So this is how you can find the answer. So the answer for this question is D. For question number 9, it is given to us an air bubble in a tank of water is rising with terminal velocity. It means the velocity is constant. The forces acting on the bubble are X, Y, and Z as shown in the figure. The upthrust on the bubble is X. Upthrust on the bubble is X, so this one simply we can label. This one is upthrust. But now we need to find out which statement about the forces is correct. So we have one force, this is one force, so I can use arrow red color for this one, and we have an other force, that is this force. So now we need to find out which one is the weight and which one is drag force, which one is weight and which one is drag force. First thing we need to understand, as this bubble is moving at a constant velocity, so it means option D is not possible. This is telling us X is greater than, so this is not possible. B is also not possible. This is telling us X is greater than Y plus Z, so this is not possible. In this case, as it is moving at a constant velocity, means it is rising with constant velocity, so it simply means that X is equal to Y plus Z. Now we need to find out which one is Y, which one is, means what is Y, what is Z. So this Y, this has to be the weight of the bubble, because it is air bubble and density of air is very small as compared with density of water. So it means Y is weight, and Z, this one has to be drag force, or simply you can say viscous force. So this is drag, or we can say this Z, this one has to be viscous force. So these points we need to understand, and now we can figure out the answer. If you look at option A, it is given to us Z is the viscous force on the bubble, Y is the weight of the bubble, and X is equal to Y plus Z. So the answer for this question is A. But if you look at option C, it is given to us Z is the weight of the bubble. So Z is the weight, but Z is not weight, it is viscous force, because in this case drag has to be greater than the weight of air bubble, because density of air is very small as compared with density of water. So drag force has to be greater as compared with weight of air bubble. So this one is wrong. So C is not possible. So the answer for this question is A. So this is how you can figure out air bubble. So the density of air is very small as compared with density of water. So the weight has to be much smaller than the drag force. For question number 10, it is given to us two blocks are at rest on a frictionless horizontal surface. One block is made of wood and the other block is made of steel. A steel ball is fired with speed V at the wooden block. The ball embeds itself in the block, and the ball and the block move together after impact, as you can see here. So this is what is happening after impact. A second identical steel ball is fired horizontally with speed V at the steel block. The steel ball then rebounds back along its original path with speed V by 2. The wooden block and steel block have equal mass. Which statement about the blocks immediately after the collision is correct? So this is basic question about conservation of momentum. So we need to apply conservation of momentum for wooden block and conservation of momentum for the steel block. And then we can find the speed and then we can figure out the answer. First of all, imagine that the mass of steel ball is m and the mass of the wooden block is capital M. So here we have m plus capital M. So this speed is v. So speed after impact we can say is capital V, or simply we can say this one is v prime. So first of all we will do for wooden block and steel ball system. So we can calculate v prime. V prime in this case, let me write down in detail so you can understand better. We will take in this case to the right is positive. If we take to the right is positive for wooden block and steel ball system, we can write down momentum before. Momentum before is only due to steel ball because this block is at rest. So we can say the initial momentum has to be equal to the final momentum. Initial momentum is mv and the final momentum will be equal to small m plus capital M times we can say v prime. V prime in this case we can calculate that will be equal to mv divided by small m plus capital M. So this is v prime. This is the speed of steel ball and wooden block. Now we can do the same for this one. So this is what is happening after. So in this case we have initial momentum. So we can start from initial momentum. P initial has to be equal to P final. P initial we have that is equal to mv, and we also in this case we will take to the right is positive. So to the right we are taking as positive. And let's say the speed of the steel block after impact, let's say is Vs, speed of the steel block. And this is moving to the right, but this ball is moving to the left. So the final momentum we will have m times Vs, because mass of steel block is also capital M and the same ball, so mass of this one is small m. And this will be, here will be minus, means we will use the plus sign, but this momentum is negative. So this will be negative V by 2 times M. Now we can simplify. So we have small m times v mean the initial speed, and this is mvs minus we have v by 2m. So we have to find out vs, then we will compare vs with v prime. So vs from here we can write down vs times m, this will be equal to mv minus mv by 2, minus on this side, this will be plus. So we can solve this one. This is mv, this is mv by 2, so this is simply 1.5 mv, and here we have vs. So we can divide this one by capital M. So this is our value of vs. This is value of vs and this is value of v prime. And this is for the wooden block. So we can write down W here for the wooden block. And this is for the steel. Now we need to compare which one is bigger. I hope you can see from here very clear. This is MV. This is multiplied by 1.5. It means this one is bigger. And this is divided by M plus capital M. This is divided by only capital M. So it means in this case, Vs is bigger than VW prime. It means the steel block will go forward with higher speed. So if we have this understanding, so we will say steel block move faster because its speed is greater. Steel block moves faster after impact, moves faster after collision. So we will be using this understanding to answer this question. Look at option A. Both blocks must travel with the same speed. No, the speed is different. We have just calculated. Steel block must travel faster than wooden block. Wonderful. So this is our answer. Wooden block must travel faster. No, it has to travel slower. The mass of the blocks and the steel ball are needed to determine which blocks travel faster. We don't need to determine. We can simply assume we can calculate. We don't need their masses. So this is how you can answer this problem. I hope this is clear to you. In this lesson, we have discussed first 10 questions. And in tomorrow's lesson, we will discuss more 10 questions and so on. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions from October-November 2022 paper 1. In today's lesson, we will start from question number 11 and we will discuss next 10 questions. In the last video, in part 01, we have done from question number 1 to question number 10. And for the solution of those questions, you can go to the channel and you can check for part 01 and you can find detailed solution about first 10 questions. And today's lesson, we will discuss next 10 questions. Let's study together. Let's improve together. For question number 11, we need to find out which diagram shows a couple formed by two forces, each of magnitude capital F acting on a rod. So first of all, we need to understand when two forces, they will form a couple. Forces will form a couple if the forces, they have equal magnitude. So the first condition is that equal magnitude. So magnitude of forces has to be the same. So we can say this is condition 1. And the second condition is that opposite direction, means forces need to act in opposite direction. So the resultant force on the rod will be equal to 0. And third condition is that there must be perpendicular distance, or simply we can say there must be separation between line of action of forces, separation. So we can use these conditions and we can try to find the answer. The first one is not possible because forces are acting in the same direction. This is not possible because the forces are not in opposite direction, because this force is at an angle, so they are not in opposite directions. So this is not possible. This is also not possible because forces are not in opposite directions and there is no separation between the line of action of forces. So this is also not possible. So this one is the answer. Because torque of a couple, when forces they form a couple, they have pure rotation. There is no translation. So they have pure rotation. So very important one. So then body will just rotate. So there will be pure rotation when the forces they form a couple. So the answer for this question is D. For question number 12, it is given to us. A student states that if an object is in equilibrium, the sum of clockwise moments about point X is equal to sum of anti-clockwise moments about a point Y. So in this case, object cannot be in equilibrium. Object is in equilibrium if sum of clockwise moments and sum of anti-clockwise moments about the same point is equal to 0. So then object can be in equilibrium. So this object can be in equilibrium if X and Y are the same point. So we can say if X and Y they are the same point, then it is possible object can be in equilibrium. So question is asking us which condition could make the student's statement correct. So condition is that X and Y they have to be the same point. If you look at option A, this is not possible because this is telling center of gravity of the object either X or Y. This is not possible. Either X or Y is the pivot of the object. This is also not possible. X and Y are at opposite ends of the object. This is also not possible because this is telling you these are two different points. So that cannot be the answer. If you look at option D, it is given to us X and Y are the same point on the object, and this one is possible because if an object is in equilibrium, sum of clockwise moments and sum of anti-clockwise moments about the same point, or you can say about any point, has to be equal to 0. Means you need to talk about the same point. It cannot be about two different points. Then object cannot be in equilibrium. So the answer for this question is D, about same point, because condition is that if object is in equilibrium, this is principle of moment, in equilibrium, then net moment about any point has to be equal to 0. So we can say net moment about any point has to be equal to 0. Net moment about any point has to be equal to 0. Or simply we can say about same point about same point on the object, about same point, sum of clockwise moment, so we can say sigma sum of clockwise moments, it has to be equal to sum of counterclockwise moments, or simply you can say anti-clockwise moments about the same point. So this is the point you need to understand. For question number 13, it is given to us a uniform rod of length 30 centimeters and weight 5.2 newtons is attached to a wall by a hinge at one end. The other end of the rod is supported by a wire so that the rod is horizontal and in equilibrium. The wire is at an angle of 40 degrees to the horizontal. We need to find out what is tension in the wire. So first of all, we need to understand there is a tension in the wire. That's the reason this is in equilibrium. And this rod is uniform. So it means its center of gravity is acting at the midpoint of this rod. So we can draw the line here. So the force of gravity is acting here. And the distance of this one is 15 centimeters. So the distance from the pivot to this point, we can write down here. This distance is equal to 15 centimeters. And this tension in this wire, it has two components. So it has one vertical component. So we can draw here. So it has one vertical component and also it has one horizontal component that is acting this way. Now, in this case, we need to understand moment. If we take our pivot point here at the hinge, then the moment due to this component of tension will be equal to 0. There will be moment only due to this component of tension. And this component of the tension is T sine of 40 degrees because this is not with angle. The component with angle is cosine and the other component is sine. So this is T sine of 40 degrees. Now simply we need to take moment about this point and we can calculate value of T. So in this case, due to vertical component of tension, this moment will be anti-clockwise. And due to weight of the rod, moment will be clockwise. So this moment will be clockwise and moment due to tension, this will be anti-clockwise. And this rod is in equilibrium. It means these two moments are equal. Means if we take moment above this point, clockwise moment has to be equal to anti-clockwise moment. So simply we can write down in this case T sine of 40 degrees, means this is our anti-clockwise moment multiplied by the distance from the pivot, perpendicular distance, and distance is 0.30, and this one has to be equal to clockwise moment, that is W times W is given, that is 5.2. So simply we can write out 5.2 times distance, that is equal to 0.15, means the perpendicular distance, and from here we can find out value of T. So T will be equal to 5.2 times 0.15 divided by 0.30 times sine of 40 degrees. And if we solve this one, our answer up to 2SF will be equal to 4.0 newtons. So the answer for this one is B. So this is how you can figure out. So the answer for this one will be B. For question number 14, it is given to us water is pumped through a nozzle at the end of a hose. The nozzle has a circular cross section of diameter 50 mm. A mass of 100 kg of water takes a time of 2.0 seconds to move through the nozzle. The density of water is 1000 kg per cubic meter. We need to find out what is speed of water in the nozzle. Now, first of all, we can sketch circular cross section. So imagine that this is the circular cross section and water is passing through this nozzle. So this much water is passing through this nozzle. And if you look at this cross sectional area for 2 seconds, how much water has passed? 100 kilogram has been passed. Now we can extend this one. Imagine that this is a cylinder, means when first time we look at this one, at time t is equal to 0 second, some water passed through this cross-sectional area and that water has reached at this point. And in this time, the amount of water passing through this point is equal to 100 kilograms. So in this case, simply we can say this distance traveled by water, let's say this distance is equal to d. Now simply we can say in this case, mass will be equal to density times volume of this cylinder, this imaginary cylinder. Let's say cross-sectional area of this one is A. So we can rewrite this one. We can say rho times A So volume is equal to A times D. Now if we divide both sides by time, so let's say we divide this side by time and also we divide this side by time. Now you can simply see from here, distance travel over time taken, this one is equal to speed. So we have mass over time. This is simply is equal to rho times A times speed. So this is the speed of the water. And for this question, we need to calculate speed of water. So we can simply say mass over time taken for the water to travel from here to here. This one has to be divided by density times cross-sectional area. And now simply we need to plug in values. In this case, we have mass that is equal to 100 kgs. Time taken is equal to 2 seconds. And density of water is 1000. And cross-sectional area we need to calculate. So we can take pi by 4 d squared. Diameter is 0.05 and we need to take square of this one because this is in millimeter. I just converted into meters. And now we can solve this one for V. If we solve this one for V, up to 2 SF, our answer will be 25 meters per second. So the answer for this question is C. A beautiful question you need to visualize. For question number 15, it is given to us a solid wooden cube rests on a horizontal surface. We need to find out what gives the pressure exerted by the weight of the cube on the horizontal surface. So the best way to answer this question is we can sketch first of all cube. So you can imagine that we have a cube. So this is, we can simply imagine is a cube and we can complete this one. So you can see this cube has all the sides equal. So we can say the length of one side, let's say is L. So this also the length of this side is L. And in this case, we need to find the value of P. And P is equal to force over area in contact. So F over A. F in this case is equal to weight of the cube. So we can say mg over A. And mass of the cube we can write down in terms of density and volume. So we can say density times volume times G divided by A. But we need to understand the volume of this cube. The volume of this cube is just simply L cube times G. And cross-sectional area of this one means cross-sectional area means this area in contact. And this area is equal to L square. So simply we can cancel this L square with this L cube. So we will get rho L times G. And this is the value of the P. If you look at given options, for option A, it is given to us, it is the product of acceleration of free fall and density of the cube. Density of the cube. So it means volume is missing and cross-sectional area that is also missing. So that is not possible. So it's simply telling you density and G, but L is missing here. So it cannot be the answer. So this is not the answer. Product of acceleration of free fall. So this is simply, in this case, they told you this is rho times G. So that's not possible. This is telling you acceleration of free fall, density and side length. So this is telling you P is equal to rho Lg. And this one is possible. So the answer for this one is P. Product of acceleration of free fall, density and area of one face of the cube. And that is not possible. Density times area times G, this is wrong. Product of acceleration of free fall, density and volume of the cube. So this is telling you P is equal to rho times V times G. Actually, this is the mass of the cube. So this is not P, this is the mass of the cube. So this is not possible. So D is wrong. This is also incorrect. So the answer for this one is B. For question number 16, we need to find out which expression could be used to calculate power. So simply we need to understand what is formula for power. First one, this is not possible because power is equal to I squared times R. So this is not possible. Power also, this is equal to work done over time. So we can simply say power is equal to work done over time and work is equal to force time displacement over time. So option B is possible. Current time, resistance square, not possible. Weight over time, not possible. So the answer for this question is B, quite straightforward. For question number 17, it is given to us a bungee jumper jumps from a platform and is decelerated by an elastic bungee cord as shown in the figure. When the jumper makes the jump, his initial gravitational potential energy is converted into kinetic energy and also into elastic potential energy in the cord. At which part of the jump are all three types of energy non-zero? Mean this person has kinetic energy and also has GPE and also EPE due to extension in the cord. So simply we can write down, first of all, if this person has GPE, there must be some height from the ground, and that will be always true. He will be higher from the ground. And kinetic energy will be if the person is moving. And elastic potential energy is possible when the string is extended. There is extension. Now, if you look at this one, now in this case, the string is not extended. So in this case, this person has GPE. So we can say this person has GPE. And this person has kinetic energy, but this person has no EPE because there is no extension. EPE is equal to 0. So means in this position, it has only two forms of energy. Now look at given options and we can try to find the answer. So EPE is possible when the string is extended. So this is the point only you need to understand. So let's try to find out the answer. On the platform before the jump, at this point, person is at rest, string is not extended. So the person has only GPE. So we can simply write down here, person has only GPE. On the way down, before the cord has started to extend. So this is the scenario when the cord has not been extended. So person will have GPE plus KE, kinetic energy. On the way down, as he decelerate means that it will decelerate when the string is extended. So in this case, person will have GPE plus KE and plus EPE. Decelerate means that the string has been extended. So the string is pulling upwards. So there is tension in the string that is pulling upwards. So this can be the answer. So C is possible answer. At the bottom of the jump, when he is stationary. So at the bottom, so we can say person has GPE if we take ground as a reference, and also the person has EPE but no kinetic energy because the person is stationary at the bottom. So the answer for this question is C. I hope this one is clear to you. So let me explain you this one with the help of animation. I have prepared one beautiful animation for you to visualize the bungee jump. So you can see here, first of all, here bungee jumper is not moving, is at rest. So you can go to the next stage. You can see here now it's moving down. So at this point it has kinetic energy and GPE but no EPE, and at this point it has all three forms of energy. It's slowing down, it's moving down, the speed is slowing down. It means string has been extended. So it has EPE, it has GPE and also kinetic energy. And if we go to the next one, at the bottom only EPE and GPE, and then it starts coming up, speeding up. When it is speeding up, and also in this case it has three forms of energy. It has EPE because string is still extended, and KE and GPE, and still rising, and finally here. This is what you need to understand about bungee jump. I hope this concept is clear to you. For question number 18, it is given to us an object is displaced horizontally to the right in a uniform vertical gravitational field. Which statement describes the change in the gravitational potential energy of the object? So first of all, we can draw a ground. Imagine that this one is the ground. This is the ground. And we can draw some arrows to show direction of gravitational field. So imagine that this is direction of gravitational field, and this gravitational field is uniform, and this is vertically downwards. And now we can also draw, in this case, one dotted line to show we move object horizontally. So this is at the same level, height is the same. Now we can imagine, in this case, we place a mass here. Let's say we place mass at this point, and we move this mass to the right to this location. Now you need to understand, in this case, let's say this is position A and this one is B. So in this case, is any work done by gravity or not? You will say work done by gravity is 0 because gravity is acting vertically down, so the work done by gravity is 0. If work done by gravity is 0, it means there is no change in gravitational potential energy. Otherwise, simply we can understand with the help of this one, gravitational potential energy will change when there is a change in height. As in this case there is no change in height, it means the change in GPE will be equal to 0. So now we can look at given options and we can try to find out the best possible answer. It decreases in direct proportion to the displacement? No, it does not decrease. Actually, it doesn't change. Option B, it does not change with the displacement. This one is right because delta H is 0. So the answer for this one is B. But if you go to C, it increases. That is also wrong, incorrect. It increases. That is also incorrect. So the answer for this one is B. Because in this case, there is no work done by force of gravity. Because gravity is down, displacement is vertical. So the work done by gravity is 0. It means there is no change in gravitational potential energy, or in a very simple way, simply you can understand, there is no change in height. So it means that there is no change in potential energy. For question number 19, it is given to us a copper wire of length 3.6 meters and diameter 1.22 mm is stretched by a force of 37 newtons. The wire obeys Hooke's law. The Young's modulus of copper is given, that is 1.17 times 10 to 11 Pascal. We need to find out which extension is caused by this force. So quite straightforward question. Simply you need to use Young's modulus. So if we start with Young's modulus, so Young's modulus is equal to stress over strain. So we can say stress over strain. Stress over strain. And stress is equal to force over cross-sectional area divided by strain, means delta L by L. So if we simplify this one, we will get FL divided by A times delta L. But question is asking us to calculate delta L. So we can rearrange, so we can write down in terms of delta L. So delta L will be equal to, in this case, FL divided by A times E. And now simply we need to plug in values. And you need to be careful with units. So force is given, that is equal to 37 newtons. L is given to us, that is 3.6 meters. We need to divide by Young's modulus, that is 1.17 times 10 to 11 Pascals, and cross-sectional area pi by 4 d square. Pi by 4 d square. So the diameter is given, that is 1.22 times 10 to negative 3 square. And now simply you need to use your calculator and you can find value of delta L. If we do calculations, value of delta L will be equal to 1.18 mm. So the closest answer to 1.18 is 0.97 mm. So the answer for this question is C. For question number 20, it is given to us a spring has spring constant K. The spring obey Hooke's law and experience extension X when a force F is applied to it. The resulting elastic potential energy of the spring is EP. E sub P. The diagram shows two of these springs joined together in parallel and hanging from a fixed beam. What is extension and total elastic potential energy of this arrangement when the same force F is applied? So first of all, we can imagine a spring. So you can imagine a spring. Let's say we have this unextended spring. Then the spring constant of this spring is given, that is K. And now we apply force on this spring. So when we apply force on this one, this is extended by certain amount. It is extended by X. And elastic potential energy stored in this one is EP. But now if we look at this given arrangement, when we have two springs, we apply force F here. So the force acting on this one, force will be distributed, means it will be divided, it will be shared by these two springs. So the force on this one will be F by 2 and force on this spring will be also F by 2. Now force become half. F is equal to K times X. This remains constant. If the force become half, it means extension also become half. Means the extension of this spring will be X by 2 and extension of this spring also will be equal to X by 2. Now we need to calculate total elastic potential energy of this arrangement. So simply we can say EPE nu. We will say EPE nu here. EPE nu will be equal to 1/2, mean EPE stored in this spring plus in this one. So we can say 1 by 2, we have force, that is F by 2, and extension in one spring, that is X by 2. And we have two springs, so again we can rewrite. So we have F by 2 and we have X by 2. So this is energy stored in each spin. So if we add these two together, so simply we can multiply by 2. So we have, in this case, this is 1/2, and we have this is F by 2, F by 2, and here we have this is X by 2. So simply in this case we can cancel this 2 with this 2. Simply we can cancel. So we left with 1 by 2 F times X by 2. If we little bit rearrange this one, we can write down 1/2 F times X, and here we have 1 by 2. If we look at energy stored in this spring, we can simply say EP. This will be equal to 1/2 F times extension, that is X. So this is X. So it means this is representing EP. So this is EP. So we can simply write on here. We have EP times 1 by 2. Half of EP means the elastic potential energy in these two springs is half of the energy stored in this one spring. So this is value of new EPE. So we can also write down here EPE new. So this one is half. So this is important. And extension in each spring is also X by 2. Means extension of this arrangement is X by 2. So we can find out our answer. If you look at A, extension is X by 2. EPE is 1 EPE. This is EPE by 2. So EPE new is a half of the EPE of single spring. So the answer for this one is A. So rest of the options, they are not possible. Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on waves from October-November 2022 paper 1. In the last two videos, in part 01 and part 02, we have discussed all 20 questions. And if you need solution of those questions, you can go to the channel and you can check for October-November 2022 paper 1, part 01 and part 02. And today's lesson, we will discuss all the questions on waves from this paper, and I will explain you these questions in detail so you can improve your conceptual understanding, and also you can have better understanding of these questions. Let's study together. Let's improve together. For question number 21, it is given to us the diagram shows a transverse wave on a rope. The wave is traveling from left to right. At the instant shown, the points P and Q on the rope have zero displacement and maximum displacement respectively. Which row describes the direction of the motion if any of the points P and Q at this instant? Now, first of all, we need to understand this question. We can approach using a long method, or we can approach using a shortcut, means short method. The first thing you need to understand, as in this case, wave is moving to the right. So these particles, they will follow the coming wave. They will follow the coming wave. Mean this particle will go down and this particle also will go down, because this particle will follow this part of the wave. So it will follow this part of the wave, means the coming wave. So this particle will go down and this particle will follow this part of the wave, means this is coming wave. So this particle also will go down. Now for answer, it is given to us. If you look at option A, particle P is moving down, means particle at point P is moving downward. So this one is true. And also we need to understand the particle at the top, means at this point the speed of this particle is equal to 0, and speed of particle at equilibrium, this is maximum. So we can say V is maximum. And if the particle is located at the bottom, mean this speed also will be maximum. So we can say speed will be 0, not maximum. If at the peak or at the bottom, speed will be 0. So speed here also will be equal to 0. Now based on these concepts, mean based on this understanding, we can find the answer. Particle at point P, it will follow the coming wave, so it will just go down. So we can draw the arrow. This particle will go down. Particle is here. This particle will go up because it will follow the coming wave. So particle here, this one will go up, and particle at the top, it will go down because it follow the coming wave. So this is a simple way, because for multiple multiple choice questions, you have only 1.8 minutes. So you need to understand the quick way to answer these problems. So simply you can understand particle will follow the coming way. So particle at point P, it will go downwards, and point Q at that instant, this is stationary. So it means A, this one is true, this is true, this is true. So the answer can be A. But if you go to B, stationary, particle at P, point P stationary, no, it has the maximum speed. This one is moving, so this one is wrong. Q is moving downwards, this is right. Stationary, not right. Moving upwards, this is wrong. Moving upwards, this is wrong. Particle at point Q stationary, this one is right. So the answer for this question is A, and this is how you can approach. For question number 22, it is given to us the period of an electromagnetic wave in a vacuum is 1.0 nanoseconds. What are the frequency and wavelength of the wave? So we need to calculate frequency of the wave and we need to calculate wavelength of the wave. Frequency of the wave simply is equal to 1 over time period, and time period of the wave is given to us. So this is 1 over 1 nanosecond. 1.0 times 10 to 9 minus 9. This is 10 to minus 9. So it simply means that the frequency will be equal to 1.0 times 10 to 9 hertz. So this one is the frequency. Now we need to calculate speed of the wave, and we need to calculate wavelength of the wave. And speed of electromagnetic wave is in the vacuum. All electromagnetic waves, they have the same speed, and speed is equal to speed of light. So we can write down lambda, the wavelength. This one will be equal to V divided by frequency. Speed of electromagnetic waves in vacuum is 3.0 times 10 to 8 meters per second, and frequency we have calculated, that is equal to 1.0 times 10 to 9. So simply we can write down this will be equal to 3.0 times 10 to minus 1, or we can say this is equal to 0.30 meter. So this is wavelength. So in this case, answer is C. For question number 23, it is given to us an observer is standing on a railway platform. A train passes the observer at constant speed while emitting the sound of constant frequency F from its whistle. What does the observer hear? So this is a typical type of question. So we can simply imagine that an observer is standing on the platform. So we can imagine observer is standing on the platform. So this one is the platform, observer is standing on this one. So we can draw first of all when the train is approaching. So at this point, train is approaching. So we can say train is approaching this observer. So this is when train is approaching. And here we can draw when the train is moving away. So we can say train is moving away from the observer. Moving away from the observer. When the train is approaching, observed frequency by the observer, this one will be greater than frequency of the source. And when this train is moving away from observer, observed frequency will be lower than frequency of the sound produced by the whistle. So this is what you need to understand to answer this problem. Now let's try to find out the answer. For option A, it is given to a sound of decreasing frequency. Actually, sound frequency will be constant. It will be higher or it will be lower. Decreasing frequency, this one is wrong because this is when the train is approaching. Increasing frequency, frequency will not increase. Actually, frequency, when if the speed is constant, there will be constant frequency higher and constant frequency lower when the source is moving away. So option A is incorrect. If you look at option B, sound of higher frequency, and frequency will be constant. So this is possible when the train is approaching higher than F, and lower frequency than F as the train moves away. So this is possible answer. If we go to C, sound of lower frequency than F, train approaches, this is wrong. This has to be higher. This is higher, this is wrong. It has to be lower when moves away. Sound of an increasing frequency as the train approaches and as it moves away. Increasing frequency, frequency will be constant but higher when the source is approaching, constant and lower when the source is moving away. So this is also wrong. So the answer for this question is B. For question number 24, we need to find out which organisms have a length that is equal to the wavelength in free space of an electromagnetic wave that is visible to the human eyes. So this question is simply about visible light, the wavelength of visible light. And wavelength of visible light is about wavelength of visible light is about 400 nanometer to 700 nanometer. And 1 nanometer, if you look at these answers, they are given in micrometer, so it's better we can write down this one in micrometer. 1 micrometer, 1 micrometer is equal to 1000 nanometer, or simply we can say 1 nanometer. This is equal to 10 to minus 3 micrometer, and we can change this one into micrometers. So we have 400, so let's try to convert this one. 400 nanometer, we can say this is 400 nanometer. We want to convert this one into micrometer, so we can divide by 1 nanometer, and 1 nanometer is equal to 10 to minus 3 micrometer. So nanometer, we can cancel the nanometer, so simply we left with 400 times 10 to minus 3 micrometer. It simply means that this is equal to 0.40 micrometer. So now from here we can simply write down wavelength of visible light. This one will be equal to 0.4 micrometer to 0.7 micrometer. Now simply we can find the answer. If you look at the first option, this is 0.5 and this is in this range. So our answer for this question is A. This is not possible because this is 5, so this is not possible. 50 not possible, 100 not possible. So the answer for this question is A. For question number 25, it is given to us two progressive waves overlap. What is an essential condition for the two waves to form a stationary waves? The waves are longitudinal. This is not necessary. I mean, this is not essential condition because transverse waves, they can also form stationary waves. The waves are polarized. This is also not requirement for formation of stationary waves. The waves travel in opposite direction. This is the requirement. The waves have to travel in opposite directions. The wave travel in the same direction. This is not required for stationary waves, but this is required for beats, and that is not part of your syllabus. So the answer for this question is C. The waves must be traveling in opposite directions so they can form stationary wave. For question number 26, it is given to us in an experiment to produce stationary sound wave in air, a fine powder is initially evenly distributed along the length of a horizontal glass tube which is closed at one end. At the open end of the tube, a loudspeaker emits sound wave of constant wavelength. A stationary wave is formed and the powder accumulates in equally spaced piles as shown in the figure. This statement explains the positions of the piles of powder within the tube. Now in this case we are talking about stationary sound wave. And in sound wave, particles of the medium, they move along direction of the wave, means parallel to the wave. So first thing we need to understand. And the second thing we need to understand, particles on two sides of same node, they move in opposite directions. So let's say we have a node here. So this point is a node. Let's say here we have, this one is antinode. So this one is antinode. And here let's say we have also antinode. Now we need to understand how particles will move. First of all, imagine that particle on this side of the node, let's say they're moving to the right, and the particle on the right side, they will be moving to the left. So these particles, they will be moving in opposite directions. So this point is very important. You need to understand, on two sides of the same node, particles move in opposite directions. Means they are in opposite directions, or simply you can say in antiphase. So opposite directions, or you can say antiphase. So the phase difference is equal to 180 degrees. Opposite directions, phase difference is equal to 180 degrees. And this is the knowledge you need to answer this problem. So if this is node, let's say you can take any point for example. So you need to understand, as in case of this node, powder means particle of medium, they will move in opposite direction. So what will happen at this point? Powder will accumulate. So we will see powder that will accumulate. So we'll see a pile of powder at the nodes. So it means these points are nodes because particles here, they will move to the right. Just imagine that. And particles here, they will move to the left. So powder will accumulate at these points, and these points, they will be nodes. Means they have minimum amplitude. Now let's try to find the answer. If you have understanding of this one, now easily you can find the answer. The piles are where air molecules vibrate with maximum, no, minimum amplitude, because nodes, they have minimum amplitude. The pulse are where molecules vibrate with minimum amplitude. Yes, because on other side particles have higher amplitude, so they will push piles of powder towards node. So at node there will be piles of powder. So this can be the possible answer. So this one is possible answer. The piles are where air molecules vibrate with the highest frequency. Actually, all wavelength is constant of this wave. It means all molecules, they have the same frequency. So this one is wrong. The pulse wave molecules vibrate vertically. Molecules are not vibrating vertically. They move along direction of wave because we are talking about stationary sound wave. So this one is also incorrect. So the answer is B. This is the point you need to understand. On two sides of same node, particles move in opposite directions, or simply you can say they have phase difference of 180 degrees. So powder will move, means from this side powder will move to the right, this side powder will move to the left, means those are medium particles. So powder will be accumulated at nodes. So this is how we can approach this problem. For question number 27, it is given to us a sound wave of wavelength 0.50 meter passes through a doorway of width 1.0 meter between two rooms. Which change increases the amount of diffraction that takes place? Typical type of question about diffraction. So first of all, we need to understand when significant diffraction will take place. What is condition for that? Significant diffraction. Significant diffraction takes place. Significant diffraction. It will take place if wavelength is about equal to the gap size. Is equal to gap size. So diffraction will be significant. Now, if we increase the wavelength, if we increase lambda, but we keep this gap size same, in this case, there will be more diffraction. We will say there will be more diffraction. So this is one thing you need to understand. There will be more diffraction. But if we keep gap size same and we decrease this wavelength, there will be less diffraction. So if you have understanding of this one, now simply you can find the answer. If you look at option A, double the amplitude of the sound wave, it has no effect on diffraction amplitude. So it means this option is incorrect. Double the width of the doorway, if you increase this one, you keep this one same, there will be less diffraction. So there will be less diffraction. So we need more diffraction. So it means B is also incorrect. So this is incorrect. Half the frequency of the sound wave. So if we decrease the frequency, it means that we are increasing the wavelength. If we keep gap size same and we increase the wavelength, this one will be equal to this one. We'll be getting closer. So it means in this case, we will observe more diffraction, because when frequency is half, wavelength is double. So double means this is 0.5 double, this is 1.0. So there will be significant diffraction. It means diffraction will increase. So this one is possible answer. Half the period of the sound wave. If period is half, it means frequency is double. Frequency double means wavelength is half. Means this will be 0.25. There will be less diffraction. So means there will be less diffraction. So D is also not possible answer. So the answer for this question is C. Typical type of question, and this is the knowledge you need for this type of problems. For question number 28, it is given to us a light source consists of a vertical slit illuminated by red light and violet light. The wavelength of red light is approximately twice the wavelength of violet light. A parallel vertical double slit is placed nearby. A white screen is placed so that fringes are formed on the screen. Which graph best represents the interference fringes formed on the screen? So this question is about double slit. For double slit, we need to understand fringe spacing x. This is equal to lambda d divided by a. A is slit separation, distance between slits, center to center. So this is slit separation. So we can write down this is slit separation. And d is the distance between double slit and screen. So simply we can say this one is the distance. Now in this case we have two lights. One is red and one is violet. And it is given to us that the wavelength of the red light, this one is equal to 2 times of the wavelength of violet light. So we can say 2 times of V. Better we can say 2 times of wavelength of violet light. So we can write down wavelength of violet light. So we can say 2 times of wavelength of violet light. Now we can compare red and violet we can compare. So first of all, we can write down for the violet. Violet, and on this side, we can write down for the red. So this one is for red. For red light, we need to understand first order fringe spacing. So I will be writing here first order. The fringe spacing, we can say x1, that one will be equal to lambda of red times d divided by a. But if we compare this one with violet light, we can say x1 in this case will be equal to 2 times of lambda of the violet times d divided by a, because the wavelength of red light is twice the wavelength of the violet. So it will be at a distance 2 lambda capital D divided by A, and this is wavelength of violet light. So this is the first order. Now if we write down for the violet light, the first order, we can say x1. This one will be equal to lambda capital D divided by A. This will be the first order. And the second order fringe, this one will be equal to 2 times lambda capital D divided by A. Now if you compare this x2 with x1, they are the same. So it means where we see the second order fringe of violet, at the same we will see the first order of red. So this is what this is telling us. So in this case, I can also write down x1 is equal to x2. So I can say that is equal to x2 means for the violet. It simply means that where we see first order of red, at the same position we will see second order of violet. And that's the point you need to understand. If you got this point, now we can find the answer. And also we need to understand at the center means zero order, central maxima. We will see violet and we will see red. We will see the combination of these two. And if I draw here, first of all, you will see the violet. You will see violet here. And at this point, the second order, you will see violet and you will see the red overlapping at this point. So I can simply draw here overlapping. At bottom side, we will also see here, first of all, violet. We will see violet here, and here we will see the second order of violet, but this will be overlapped by first order of red. Now if you have this understanding, so we can find the answer. If you look at option A, this one is 100% not possible, because this is telling us the minima at that one. Here will be maxima, so this is not possible. This is telling us only violet, no red. This is also not possible. And if you look at this one, it's telling us red is inside, violet is on the outer side. That is not possible. If you look at this order here, it must be violet, not red. So this one is wrong. So this is also not possible. Here it should be violet. It should be violet, not red, because first order violet, then red. Now if you look at this one, you will see you have violet, you have red, violet and red. So it means that this one is possible, because first order we will see this is violet, means you will see the violet here, and here you will see violet and red, and also violet and red together we will see, as you can see here. So this side is also true. It means this one is possible answer. So C is the possible answer. So this is possible answer. Let's try to understand a little bit more about this one. Maybe some of you will be confused, or maybe you need some more detail. Why this one is inside? Why the violet is inside and the red is on the outer side? The reason is that we have seen from here, as the fringe spacing for red is greater than fringe spacing for the red, as this is 2 times greater than the fringe spacing for the violet. It also means that the size of the bright fringes of red is greater than the size of bright fringes of violet. So that's the reason we see in this case red on the outer side and you see violet means inside. So that's the reason. So the red bright fringes, these are wider. The size is bigger than the size of the violet. So that's the reason inner side we have violet and outer side we have red bright fringes because the size is bigger. So that's point you need to understand. So that's the reason we see, if you look here, we have the red outside and we have violet inside. So you can see this is the red, this one is outside, and inside we have this one is violet. So inside we have violet. Let me use different color. So let me use this color for the violet. So we have violet inside and we have red outside because the size of bright fringes of red is greater than the size of bright fringes of violet. So that's the reason you see outside. So if fringe spacing is greater, it also means that the size of the fringes is also greater. For question number 29, we need to find out which property of a light wave can be determined using a diffraction grating. If you look at formula of diffraction grating, we have d sine of theta. This is equal to n times lambda. So from here we can find out the lambda of a wave using diffraction grating. So we can find out wavelength of a wave, and that is property of a wave. So simply answer for this question has to be D, because we can determine the wavelength of a wave using diffraction grating. Amplitude, not possible. Intensity, we cannot determine. Speed, we cannot determine. So the answer for this one is D. Welcome to A-Level and EP Physics. In today's lesson, we will discuss past paper questions on electricity and radioactivity from October-November 2022, paper 1. In today's lesson, we will discuss these questions in detail as always, so you can improve your conceptual understanding and you can have better understanding of these questions. Let's study together, let's improve together. For question number 30, it is given to us there is an electric current in a copper wire. Which statement describing the average drift speed of the charge carriers in the wire is correct? So question is about average drift speed. So we can simply start with transport equation. I is equal to NQVA and V is the average drift speed. So we can make V the subject. So we can write down V is equal to I over NQA. And from here we can see V is directly proportional to current and V is inversely proportional to cross-sectional area. And now we can try to find out the best possible answer. If you look at option A, it is given to us average drift speed is close to speed of light. This speed is very, very high. Actually, average drift speed, it can be around 1 meter per second, even smaller than that. So it cannot be this high. So this is the speed of light. So this is not possible answer. If we go to next one, it is proportional. Actually, this is inversely proportional. So this one is also not possible answer. This is telling you it is proportional, but actually V is inversely proportional. If we go to option C, it is proportional to length of the wire. No, it is not proportional to length of wire. So this is also not possible. If we go to next one, it is proportional to magnitude of current. So it is proportional to magnitude of current. So this is our answer for this problem. So this is how you can approach. So you need to understand average drift speed means average drift velocity is very, very small. It can be 1 meter, even smaller than that. So it cannot be a very big number. So that's the reason option A is not possible. For question number 31, it is given to us a battery with a constant internal resistance is connected to a resistor of resistance 250 ohms as shown in the figure. The current in the resistor is 40 milliamps for a time of 60 seconds. During the time, 6.0 joule of energy is dissipated by the internal resistance. What is the energy supplied to the external resistor during the 60 seconds? And electromotive force of the battery. Electromotive force of the battery. So first of all, in this case, we will try to calculate electromotive force of the battery. In order to calculate electromotive force of the battery, so simply we can attach one voltmeter here. So if we have reading on this voltmeter, and also if we have potential drop across this internal resistance, then we can calculate EMF of the power supply. So EMF simply will be equal to V1 plus V2. So first of all, we need to calculate V1 and V2. In order to calculate V2, so simply we can write down here V2 will be equal to current passing through this resistor times this resistance. Current passing through this one is 40 milliamps, so we can say this is 40 times 10 to minus 3 times resistance of this resistor, that is 250. So if we solve this one, our answer will be equal to 10 volts. So this is value of V1. So this is V1. So this one is V1 because we are talking about potential drop across this resistor. So this one is V1. Now we need to calculate V2. In order to calculate V2, we have current, we have time, and we have energy. So simply in this case, we can write down E will be equal to VI times T. We need to calculate, in this case, V means the value of potential drop across this resistor. So simply we can say in this case V2 will be equal to E divided by I times T. So the value of energy is given to us, that is equal to 6 joules. So simply you can plug here, this is 6 joules, and current passing through this one is given, that is 40 milliamps. So this is 40 milliamps, and time is given to us, that is 60. So if we solve this one, we can find out value of V2, and V2 in this case will be equal to 2.5 volts. So this one will be equal to 2.5 volts. So this is value of V2. So simply we can plug in values here now. We have 10 plus 2.5. So the final answer will be equal to 12.5 volts. So this is value of EMF of this power supply. Now we need to calculate energy supply to external resistor. Actually, if you look at these given options, we have only EMF equal to 12.5, only this value. So it means that answer is D. So answer is D. So let's try to find out energy supply to external resistor. So we can calculate value of E. So I will say this is capital R, means this resistor is capital R. So energy in this case will be equal to I square times R times T. You can also use VIT, otherwise you can use this one, it is the same. So we have value of current here, that is 40 times 10 to minus 3 square, and the resistance of this resistor is 250, and time is 60 seconds. So if we solve this one, our answer will be equal to 24 joules. So the answer for this problem is D. So this is how you can figure out step by step. Here you can also use formula VIT. You can also use this one. You can use VIT. So you can also use, because we have value of V across this one, means the potential difference across this one. You can also use this one. For question number 32, we need to find out which component has the IV graph as shown in the figure. And if you look at this graph, this is a typical graph for filament lamp. We can also extend this one and we can see better picture of this one. So the shape of the graph is like this, and this is typical graph for filament lamp. This graph is telling us that the resistance is increasing with the increase in voltage. So as V is increasing, resistance of this component is increasing. So this one is filament lamp. For this question, it is given to us two wires P and Q have the same resistance. Wire Q is made of material that has twice the resistivity of the material used to make wire P. The diameter of wire Q is twice the diameter of wire P, and we need to find out the ratio between length of wire P and length of wire Q. So the best way to start this problem is simply we can say R is equal to rho L by A. And in this case, it is given to us they have the same resistance. So we can write down in this case rho P times LP over AP. This one has to be equal to rho Q times LQ divided by AQ. So because they have the same resistance, it means these two are equal. Now in this case, it is given to us that resistivity of Q is twice the resistivity of P, and it is also given to us that diameter of Q is also twice the diameter of P. So these things are given to us. Now simply we need to use and we can find the answer. So for this question, we need to find the ratio. We need to find out the ratio between length of P and length of Q. So we can rearrange this one. So we can write down, in this case, we will have rho P and this is LP. We will have AQ and this one will be equal to rho Q times LQ and times AP. We need to find ratio between LP. So we can write down LP divided by LQ. This one will be equal to rho Q times AP divided by rho P times AQ. And now we can plug in values. So we have LP divided by LQ. Rho Q is equal to 2 times of rho P. So we can replace with rho P. And we have cross-sectional area of P. And cross-sectional area, simply we can write down, this is pi by 4 diameter of P. So we can say this is dP square divided by, we have pi by 4 dQ. dQ is equal to 2 times of dP. So we can say this is 2 dP square. 2 dP square. And here we can simply cancel pi by 4 with pi by 4. And now if we simplify this one, we will get here this is 2 rho P divided by rho P, and here we will get this is dP square, and here we will get 4 dP square. So this will be 4 dP square. Now simply we need to cancel out. So rho we can cancel with rho P, dP square we can cancel with dP square. So we left with 1 by 2, and this one is the answer. So you can do these steps. And other way to understand this problem is, as in this case, the resistivity of Q is twice. It means due to resistivity, its resistance will increase by 2 times. And as the diameter of Q is 2 times, so its cross-sectional area will be 4 times. So due to cross-sectional area, its resistance will decrease by 4 times. So overall, resistance of Q will be 1/2 of the resistance of P. So you can also use factor method, you can figure out. But this is a proper approach to answer this type of problems. So the answer for this question is C. So this one is the answer. For question number 34, it is given to us a voltmeter reads 9.0 volts when it is connected across the terminals of a battery. When a resistor of resistance 11.0 ohms is connected in parallel with the battery, the voltmeter reading changes to 8.80 volts. What is the internal resistance of the battery? So first of all, if you look at this circuit, in this circuit you can see we have battery, so it has EMF. Let's say it has voltage lost. We can say V lost in the internal resistance, and we have voltmeter. So these components, they are connected in series. So simply we can say in this case EMF minus V for the voltmeter minus, we can say V lost. This one has to be equal to 0. And in this case, reading across voltmeter is equal to 9. So we can say E minus 9 minus. Now we need to understand in this case, this is ideal voltmeter. So simply we can say this one is ideal voltmeter. So ideal voltmeter, its resistance is infinite. So R is infinite. If resistance of this one is infinite, it means the potential drop across this one almost will be equal to EMF of the power supply. So it simply means that EMF is equal to about 9.00 volts. So it simply means that V lost is equal to 0. So simply we can say from here EMF is equal to 9 volts. So very important point, you need to understand these components are connected in series. So we have value of EMF from here. Now if we go to the second circuit, in this case it is given to us terminal potential difference is equal to 8.80. So it simply means that if you connect your voltmeter here, the reading on this voltmeter has to be equal to 8.800 8.0 volts. Now we have potential difference across the resistor and we have its resistance. So we can find out value of I, means current in the circuit. Now simply we can find out value of I. So I will be equal to 8.800 divided by 11.0, and from here we will get I is equal to 0.8 amps. Let's say internal resistance is small r. Now we can see all these components, they are connected in series, mean these three components, they are connected in series. So we can say EMF in this case has to be equal to I times this resistance 11.0 plus small r, and EMF in this case is equal to 9, and we have value of I that is equal to 8, and here we have this is 11.0 plus r. So from here we can say 9 divided by 0.8, this one has to be equal to 11.0 plus r. Now we can solve this one for value of r. So r will be simply equal to, in this case, 9 divided by 0.8 minus 11. And if we solve this one, our final answer will be equal to 0.250 ohms. So this is value of internal resistance. And this is how you can answer this problem. So the answer for this question is B. For question number 35, it is given to us each of the Kirchhoff's laws is linked to the conservation of a physical quantity. Which conserved physical quantities are used in the derivation of Kirchhoff's first law and Kirchhoff's second law? Kirchhoff's first law is based on conservation of charge. Kirchhoff's first law is based on conservation of charge. And Kirchhoff's second law, this is based on conservation of energy. So if we look at given options now, Kirchhoff's first law is based on conservation of charge, so this one is right. Second law is based on conservation of energy. So the answer for this question is C. For question number 36, it is given to us 3 batteries and 3 identical resistors are connected in a circuit PQR as shown in the figure. Batteries have negligible internal resistance, and what is the potential difference between the points P and Q? What is potential difference between these 2 points? So first of all, this circuit look little bit complex circuit. So we can redraw this circuit. So if we redraw this circuit, we can start from this point. So we have R here, then we have one battery that is connected in series. So this is one battery. We can simply redraw this battery, and EMF of this battery is given, and after this battery one resistor is connected, and let's say resistance of this resistor is capital R, and EMF of this battery is 8.4 volts. And after this one, here is a point P, we can mark this as point P, and after point P we have one battery. So this is the battery. So here we have positive terminal, negative terminal, and EMF of this battery is given, that is equal to 9.6 volts. After this battery we have a resistor. This resistor is also capital R because resistors are identical, and after this one is a point Q, so we can mark this as point Q. After point Q we have a resistor, and resistance of this resistor is also capital R, and then we have a battery. We have positive terminal, then we have negative terminal, then there are many cells connected together. We have positive terminal and negative terminal. EMF of this power supply is given, that is 6.3 volts. So in order to answer this question, simply you can connect these two sides with a wire. Need these 2 points. So this point is also R, so simply we can connect with wire, and this is ideal wire, there is no any potential drop in this wire. And question is asking us to calculate potential difference between points P and Q. So we have point P here, we have point Q here. So simply if we connect a voltmeter between these 2 points, question is asking us what is reading on this one. So in order to find the reading on this one, simply we can say VPQ, potential difference between P and Q, that is what we need to find out. So in order to find potential difference between P and Q, first of all we can find out what is net EMF of the circuit. Net EMF. if you look at these batteries, this battery, its positive terminal is connected with negative terminal. It means these two batteries are connected in series. So simply we can say 9.6 plus 6.3. But if you look at this battery, it has positive terminal that is connected with positive terminal of this battery. It means this battery is connected in reverse order. So we have to subtract this one. So we will write down here 8.4. Now if we solve this, we will get 7.5 volts. So this is net EMF of the circuit. Now we can also calculate net current in the circuit. That will be equal to net EMF of this circuit divided by total resistance of the circuit. That is equal to 3R, because we have 3 identical resistors connected in series. So simply we can divide this one by 3R. And net EMF is equal to 7.5 divided by 3R. Or simply we can say this is equal to 2.5 divided by capital R. Now we need to find out potential difference between point P and Q. So first thing we need to understand, what is direction of current flow. So these two batteries are connected in series and this is the positive terminal. It means current in this case will flow this way. So this is direction of current. So simply we can also draw arrow here. Current will flow like this. So current will flow in this case anti-clockwise. We need to find out potential difference between P and Q. So let's start from this point. If we go from this point, we cross this battery. We go from positive terminal to negative terminal. It means in this case, potential will drop. So we will write down here negative 9.6. If we cross this resistor, we will go in a direction that is opposite to the current flow. It means we will gain voltage, means the potential will increase in this case. As potential will increase when we cross this resistor, so we will say this is plus resistance of this resistor is capital R, and current passing through this resistor is equal to 2.5 divided by R. So we can say this is 2.5 divided by capital R. So this R we can cancel with this, and so simply we left with, in this case, 9. So we left with 7.1. This is minus. Let's try to understand what this negative sign is telling us. Negative sign is simply telling us that point P is at higher potential as compared with point Q. So if you go from P to Q, potential is decreasing. If you go from Q to P, potential is increasing. So this is what negative sign is telling us. That question is asking us to find the potential difference. So the potential difference between point P and Q is equal to 7.1. So the answer for this question is C. So this is how you can approach this type of problems. For question number 37, it is given to us a cell of electromotive force 2 volts and negligible internal resistance is connected to a uniform resistance wire of resistance 10 ohms and length 1.0 meter. Z is a connection that can be made at any position along the resistance wire. A galvanometer is connected between point P and point Q. Means galvanometer is connected here. A typical potentiometer question. A new source of electromotive force of 8 millivolts is connected between points P and Q. The EMF of new source is determined by changing the position of Z until the reading on galvanometer is 0. Which change to the circuit can give us a much more precise value for the EMF of the new source to be obtained. So the first thing we need to understand, quite long question, much more precise reading. In order to get much more precise reading along this wire, we need the change in potential per unit length as small as possible. It simply means that we want reading on voltmeter between these 2 points very close to 8 millivolts. Just assume that we want 8 millivolts. This is extreme case, 8 millivolts. Or you can also assume 9 millivolts, 8 millivolts. So it simply means that 8 millivolts divided by 100 centimeters. So the change in this case will be 0.08 millivolt per centimeter. So it means if you move slider on this one by 1 centimeter, the change in potential that will be equal to 0.08 millivolts. So in this case, we will get the most precise reading for the cell. I mean for this test cell. Test cell is connected here. So simply you can draw here. Test cell is connected here. The power supply is connected here. So we can get the most precise reading. So in order to get 8 millivolts here, we have to connect a resistor in series with this power supply. And now we need to find out resistance of that resistor. Imagine that this resistor is capital R. Now if the reading along this wire is 8 millivolt, what will be the potential difference across this resistor? So we can find out value of that V. And so we can find out V means the reading of this voltmeter, that will be equal to 2 minus 8 millivolts. 8 millivolts means 0.008. So if we solve this one, we will get our answer 1.992 volts. So this has to be the reading on this voltmeter. Now we can find out value of current. Value of I means current in this circuit, So we can find out current in this circuit. So in this circuit we have this resistor. Resistance of this resistor is given to us, that is 10. So we can find value of current. So we have potential difference across this wire, that is 8 millivolts, and this is divided by 10. And so in this case our final answer will be 0.0008 amps. So this is value of current. Now we need to find out value of this resistance. So in order to find value of this resistance, we have potential difference across that one, that is equal to 1.992 divided by current 0.0008. If we solve this one, our answer will be equal to 2490 ohms. So if we connect this resistance in series with the resistor, we can get 8 millivolts here, and this will give us 0.08 millivolt per centimeter. If we move slightly by 1 centimeter, this will give us change in potential by this. So in this case, we can get the most precise value for the EMF of this cell. Now let's look at given options. So first one, add a resistor of resistance 0.1. This will not give us a precise value, very small resistance. Next one, add a resistor of resistance 1000 ohms in series with cell. This can give us precise value. Next one is 10 ohm. Next one is 8 ohms. So the best option is B. Even we can connect resistor of this resistance to get the most precise value. But in the options we have the maximum resistance, that is 1000 ohms. So we will choose 1000. So the answer for this one is B. So this is how you can approach this problem. A very nice question to understand potentiometer. For question number 38, we need to find out which statement about the alpha particle scattering experiment provides evidence for the existence of the nucleus. In alpha particle scattering experiment, when we fired alpha particles, we observed that most of the alpha particles, they went straight through the gold foil. A tiny amount, means a small amount of alpha particles deflected through large angles, means greater than 90 degrees. And from that we concluded that there is nucleus at the center of the atom. So now if you look at given options, simply you can find out. Option A is telling us a tiny proportion of alpha particles were deflected through large angle. And from this we concluded that there is nucleus at the center of the atom. So the answer for this question is A. For question number 39, it is given to us a nucleus X undergoes beta plus decay. The products are a nucleus Y with proton number Z and a beta plus particle and another particle P. What is particle P and what is the proton number of nucleus X? So first thing we need to understand, this is beta plus decay. Beta plus decay. So you have plus 1 here. So the proton number of X has to be Z plus 1. Z plus 1 here, Z plus 1 here. Now we need to understand this particle. So what is this particle? As this is antiparticle of electron, so the lepton number of this one is minus 1. So this one has to be neutrino, electron neutrino. So its lepton number is plus 1 to conserve lepton number. So simply this one has to be neutrino. So simply you can say this one has to be neutrino. And so particle is neutrino. So the answer can be C, our answer can be D. Answer has to be D because the proton number is Z plus 1. So the answer for this question is D. So simply you can understand if this is antiparticle of electron, this one has to be neutrino to conserve lepton number. For question number 40, it is given to us a particle consists of two up quarks and a charm quark. What is the charge of this particle expressed in terms of the elementary charge E? So first thing we need to understand up quark. The charge on up quark is plus 2 by 3e, and charge on the charm quark is also plus 2 by 3e. Now we need to find out the total charge Q. So this one we need to find out. So the total charge will be equal to 2 times the charge on one up quark plus the charge on one single charm quark. Now if we add this one, we will get 4 by 3e plus 2 by 3e. So simply in this case we will get 6e by 3. So this one will be equal to plus 2e. So the answer for this question is D. Pretty straightforward one if you understand the charge on each quark. Charge on up quark, charge on top quark, charge on charm quark is plus 2 by 3e. And on bottom quark, strange quark and down quark, charge is minus 1 by 3e. So let me write down here. Charge on the top quark, charge on up quark and charge on the charm quark. They have the same charge 2 by 3e, and charge on the bottom quark, charge on down quark and charge on the strange quark. So better we can use small p here for the bottom quark. So the charge on the bottom quark, all of them they have charge minus 1 over 3e. So then you can just plug in and you can add and you can find the answer. And that's all for this video and also for this paper. I hope this paper is clear to you. If you have any questions about this one, please leave your questions in comments and I will answer as soon as possible.